Okay, so we're going to cover titration calculations. Now, titration calculations generally are asking you to either find the concentration or the volume of a particular acid or alkaline. So in order for us to work out the concentration of something, we are going to need to know the number of moles, Nm, and we're also going to need to know the volume. In order for us to work out the volume, we would need to know the number of moles, Nm, and the concentration. So if I put this into a triangle, we have number of moles, concentration, volume. And just to explain how this works, so if I wanted to know what the volume is, that is going to be number of moles divided by concentration. And if I wanted to know what concentration is going to equal, that is going to be number of moles divided by volume, as you can see here. So I'm just going to leave that equation in the corner there for the time being. Okay, so let's imagine I have a situation where I have an alkaline, such as sodium hydroxide, and I have an acid, such as hydrochloric acid, and that is going to react in a neutralization reaction to create NaCl and H2. So what are we looking at with this? Well, what we can see here is we can see that 1 mole of sodium hydroxide has reacted with 1 mole of hydrochloric acid, and that's going to be of importance later. Now, if I'm given a question, and my question is that I have a volume of sodium hydroxide of, say, for example, 20 dm cubed. This is kind of unrealistic numbers, but we're just going to go with them because they're simple. And the concentration of sodium hydroxide is 2 moles per dm cubed. And I was also given the volume of hydrochloric acid, 5 dm cubed. I may be asked, what is the concentration of hydrochloric acid that has been used in order to neutralize the sodium hydroxide? So the step 1 that I'm going to do, step 1 is that I'm going to calculate or find the mole or number of moles for the known alkaline or acid. Now, we're only going to be able to work out the number of moles if we have the concentration and the volume. So I have the concentration of 2 moles per dm cubed and the volume of 20 dm cubed for my sodium hydroxide. So therefore, I'm going to carry out the equation number of moles equals concentration 2 times volume 20. So that's going to give me a number of moles of 40 moles, which is a pretty obscene number, but we're just going to pretend that this is what we're using. So step 2, I need to find the number of moles of the unknown, and the unknown is going to be the one that I'm trying to find out. So this is going to be my HCl here. Now what I need to do is I need to look at my ratios on my equation, and this one's quite simple because 1 mole of sodium hydroxide reacts with 1 mole of hydrochloric acid. So therefore, if I have 40 moles of sodium hydroxide, I'm going to have 40 moles of hydrochloric acid. If this was different, if, say, for example, I had a big 2 here, which I don't, but if I did, then that would be implying that I would have 40 moles of hydrochloric acid reacting with twice as many moles, 80 moles of hydrochloric acid. I don't, I just got a ratio of 1 to 1, so that makes that quite simple for me to be able to work out the number of moles of my unknown which is going to be 40 moles. So then I'm going to go to step 3, and step 3 is going to involve me calculating what I need to work out. So I need to calculate, in this case, concentration. It may be in some questions that they're phrased differently and I might need to calculate volume, but we'll talk about that later. So now I'm going to calculate the concentration of the unknown. So in order for me to do this, I need to look at my triangle here. Concentration is going to be equal to the number of moles divided by the volume. My number of moles of the unknown is 40. My volume is 5. So I'm going to do 40 divided by 5, and this is going to give me my concentration. And that is therefore going to equal 8 moles per dm cubed. So my answer is 8 moles per dm cubed. Okay, so let's imagine that this question was different, and this question was wanting me to work out what the volume of hydrochloric acid that is needed to neutralize 20 dm cubed of sodium hydroxide with a concentration of 2 moles per dm cubed. So I'm going to do exactly the same steps. So what I'm going to do is find the number of moles of the known, and in order for me to do that, I'm going to need to do number of moles is going to be my concentration times my volume. So concentration 20 times my volume, concentration 2 times my volume 20 gives me 40. Then find the number of moles of the unknown, and I'm going to put here the ratio because this is where we need to use our ratio 1 to 1. So that's quite simple. That is going to give me 40 moles as well. So far, everything is similar to what it was last question. Then I need to calculate now, this time, the volume. So therefore, I'm going to look at my equation here. Calculating the volume is going to be number of moles divided by concentration. My number of moles is 40, and my concentration here is 8. And 40 divided by 8 gives me 5. And that is going to be dm cubed. So therefore I'm going to write 5 dm cubed here, like so. Okay, so let's get rid of this and let's keep our steps. And now let's get introduced into a slightly trickier equation. So let's say, for example, I have a situation now where I have got 2 NaOH plus, which is 2 sodium hydroxide moles, plus sulfuric acid is reacting to form sodium and sulfate and my 2H2O. And then if I was to write this down as a question rather than writing it down as underneath the various parts, if I said that I had, let's say, 0.2 dm cubed volume of NaOH and a concentration of, let's go with 0.02 mole per dm cubed. And I also said that I had a concentration of, actually, let's go with volume of H2SO4 of 0.03 dm cubed. What I want to know is what is the concentration of H2SO4 that would be needed to successfully neutralize this reaction. So I want to know what is the concentration of H2SO4. Okay, so let's simplify this question by writing V for volume and writing 0.2 dm cubed, and V for volume next to my H2SO4 and writing 0.03 dm cubed. Then if we can write down the concentrations, C for concentration, so my concentration of sodium hydroxide was 0.02 mole per dm cubed, and I don't know what my concentration is for the sulfuric acid. So let's now get rid of that question because we've managed to pick apart the question and turn it into the situation that we had earlier. And let's just make that slightly bigger. That should be mole per dm cubed. Okay, so first steps first, see if you can pause the video and find the moles of the known substance, which in this case is the alkaline. So if you pause the video using this equation here, number of moles, see if we can do that. So hopefully we've done that, and we realize that that is going to be concentration times volume, which we can see here. And this is for the known substance, where we know the concentration and the volume of our sodium hydroxide. So my concentration, 0.02, which is here, times my volume, 0.2. And that is going to give me an answer of 0.004. Okay, so now we need to have a look at step 2, find the number of moles of the unknown, which is our sulfuric acid here. So if you have a look at the ratios, we've got 2 moles to 1 mole. So if you pause the video and try and work out how many moles you think you will have of sulfuric acid, the H2SO4. Okay, so hopefully you've done that. And you can see that 2 moles to 1 mole means that you're going to have half the amount of moles. So therefore, I'm going to take this number of moles here and I'm going to divide it by 2, which is going to give me 0.002 moles. Most of the ratios are really quite simple to work out, but step 3, calculate the concentration or the volume, and in this case it wants us to try and calculate the concentration of the unknown. So if you pause the video and see if you can do this. Okay, so hopefully you've realized that we're trying to calculate concentration, so I'm going to cover up concentration, and concentration is going to be number of moles, 0.002 divided by my volume. So my volume is 0.03, so I'm going to be doing 0.002 divided by 0.03, and that is going to give me an answer of 0.066 recurring, so I can round up to 7, 0.067 moles per dm cubed, and that's going to be my concentration. So therefore, in this case, I will have 0.067 mole per dm cubed. Now, sometimes it might be the case that they want you to answer the question not in moles per dm cubed, but in grams per dm cubed. And if this is the case, then when you get to this final stage, you're going to need to remind yourself of this equation, which is number of moles is mass times or divided by atomic formula mass. So if I want to convert number of moles here into mass, which is grams, I'm going to cover up mass. And my mass is going to be equal to my number of moles times my atomic or formula mass. So my number of moles here is 0.067 and my formula mass of H2SO4 is H, which has an atomic mass of 1, and there's 2 of them, so that's 2, plus S, which is sulfur, which is only 1 of them, and that's 32, plus O4, so that's 4 oxygens. Oxygen has an atomic mass of 16, so 16 times 4. So 16 times 4 gives me 64. 32 plus 2 gives me 34. And 64 plus 34 gives me 98. So my formula mass is 98. So therefore I'm going to do my number of moles times my atomic formula mass to turn this into grams rather than moles per dm cubed. So I'm going to do 0.067 times 98, and that is going to give me 6.566 grams per dm cubed. Okay, another little point that you just need to watch out for is if this here, the dm cubed bit at the start, is given in centimeters cubed. That's not a problem, but if it is given in centimeters cubed, you'll need to convert it into dm cubed before you do the calculation. In centimeters cubed, going into dm cubed is really simple. It's just dividing by 1000 to get it to dm cubed.